Just record this to make sure. Right? We want all the numbers that are less than 3. So I'm going to go to 3. And in order to indicate that I don't want to include 3, I use an open circle. Right? And less than 3 is this direction. You can also, it is equivalent to use a parenthesis there. That's another way of representing that you don't include the number 3. An interval is kind of a nicer way in many cases of writing this collection of numbers. An interval includes every number from the left endpoint to the right endpoint. And so in this case, the left endpoint is it goes forever. So it's negative infinity. Right? We always use a parenthesis with negative infinity. And this goes up to 3. And again, I don't want to include the number 3, so I use a parenthesis. So this is what's called interval notation. And it represents the same thing as this graph. Anytime you're using notation, you have to be really careful about how you write it. So every little symbol and part and order matters when you're writing something like this. Okay, this interval. So a different example. X bigger than or equal to -2. So normally we just have to write one of these, but when we're learning it, we want to make sure we know how to do both. So the graph, I go to -2. The difference here is because of the equal sign, -2 is also a solution. -2 needs to be included here. And so I use a solid circle. And I like to read it, X is bigger than, I read kind of from the X rather than left to right. Like -2 is less than or equal to X feels not very clear to me what that's saying, but X bigger than or equal to -2, that feels like that's telling me this, right? Which is what the solutions are. Equivalently, we can use a bracket. These are different ways of showing that we include the number -2. And then the interval, I always have to go left to right, and I include -2. It goes up to infinity. Any questions on that notation?
So I just wanted to make sure. So exactly why do you use a parenthesis on the top one and then a bracket on the second one? That's all.
Excellent question, and that's like the key thing here that we want to. It's because of this type of symbol. It's not the direction of the symbol. It's that this symbol does not include equality. So I do not want to include 3. 3 is not less than 3. So this set here, I want to include every number right up to 3. So 2.99 is fine, but not 3. And that's what this open circle or parenthesis means. Everything up to, but not quite 3. When I have an equality, and again, it doesn't matter which way the symbol is facing. That would also give me a solid circle or a bracket. It would just change the direction the arrow went. Right? When I have that equality, then I include the endpoint, and I include it by using a solid circle or a bracket. So when I see that symbol, I know I'm going to use an open circle. And then I just have to decide which direction I go, right, based off of the direction of the symbol. Other questions about this?
I have a question. My bad. Earlier, my computer was like tweaking when you was asking about questions again, but
Yeah.
number 4 on the take home work or whatever, can you do like a similar problem?
Yes. And let's, that's a good question because we hadn't covered that at all. And this is kind of leading towards that. So let me do another example or two, and then I'll get to one that's a lot like the take home work. You will see a number of problems that look something like this. So this is an inequality 2. It's not quite as simple as these, right? And so we want to solve it. The good thing is we can use all the same tools for solving equations. So adding things to both sides, multiplying and dividing on both sides, that all works the same way. The only thing to watch out for, so when I'm solving the inequality, I have to keep track of which direction this is, because that makes a big difference in my answers. So if I add the 6 here, and if I subtract the 5x, I get this. If we divide both sides by a negative or multiply by a negative, which is what I want to do here to get rid of the -3. In order to keep that inequality the same, I have to switch the direction of the sign. That's like the one thing that's different than an equation. I mean, otherwise I'm doing the same steps I would do for an equation. But I have to do the switching if I divide or multiply by a negative. And the reason for that is just like the way the numbers work. Like 1, 2, 3 is kind of moving in this direction, but the negative numbers kind of move in the opposite direction. So when I multiply by a negative, I'm kind of moving from this direction to this direction. And so I have to flip it. It's not a mathematical explanation, but it's maybe gives you a little bit of the reason why that has to be. I am not done here. I still have to write my solution. I know it's going to be an open circle or a parenthesis. Minus 10/3 is just a little bit smaller than -3, right? It's an open circle and it's x bigger than minus 10/3. So bigger than is to the right. And to be honest, whether I'm going to write this answer as an interval or a graph, I still want to think about the graph most of the time, right? Like visually seeing this is going to allow me to write the interval with a lot more confidence, because I can see what's the left endpoint and I can see the right endpoint. Right? And I can get my interval if that's what's asked for.
Do you only flip it if you can't divide it?
I only flip it when I divide both sides by a negative. So let's just see a couple examples here. 2x less than -6. So if I divide both sides by 2, I get -3. Do I have to flip the sign? It's hard in a Zoom meeting, but no, I don't, because I divided by 2. So the sign stays the same. How about here? If I divide both sides by -2, I get -2 over -6. So that's a +3. Do I have to flip the sign here?
Yes.
I do, because I divided by -2. So it's not what the answer is or whether it goes in evenly or not. It's just whether you divided or multiplied by a negative. You have to flip the sign around. Other questions? I'll say, you guys are great at questions. You could possibly be my best online class for questions. So you should give yourselves a pat on the back. It's way more fun for me, right? Because otherwise I'm just sitting here talking and I don't even know if I don't know anything right about what's going on with you guys, which is disconcerting. So okay, so a lot of the questions you see are really going to be something like this, where you do some algebra work, you get x alone, and then you write your answer either as an interval or a graph. So that's like a kind of a standard linear inequality. And it can be a little harder if I have more algebra stuff going on here, some extra terms and whatnot. But once you simplify it down, it really all sort of turn into the same general problem. Now, of course, you know that we don't like to just leave ourselves with the same general problem in math, right? We always like to kind of add something new or extra every time, right? I think sometimes perhaps you get a little tired of that, right? So I just figured this out. Why do we have to add something new on the top of it? So this is homework 8, which is called compound inequalities. A compound inequality is like a compound sentence. It's taking two of them and putting them together. We have two ways of putting them together. One is called and. In math, that's called the intersection. And it includes elements that are in both sets. So here's an example. X less than 2 and x is bigger than or equal to -1. This is a compound inequality. I know what x is less than 2 looks like, and I know what x bigger than or equal to -1 looks like. And means I'm only taking the parts that are in both of these sets. And just like before, it's really easiest to see this visually. I think that's the safest way to go about it. You can certainly do it in your head, but like if I'm doing it in my head, I'm just visualizing it in my head rather than writing it down on paper. But either way, I'm looking at how these two sets look. So x is less than 2. I know that's an open circle at 2. Less than 2 means to the left. X bigger than or equal to -1. That means a solid circle at -1. X bigger than or equal to means to the right. At the moment, this isn't the solution because the solution are the things that are both of these. But the graph here shows me where these are both happening. It's where they overlap. So if I were to graph it, I'll do it down below because I got a lot going on up above. I go from -1 up to 2. -1 is in there because -1 is in both of the sets, but 2 is not because 2 is here, but not in that set. And as an interval, this would be -1 up to 2. That's often how we would write our answers to these as intervals.
Are you looking for like that on the take home work?
Let me take a look and see what I said. I can't remember what I said on the take home work. If I don't say, you're welcome to graph it or if I don't say, you can graph your answer or write it as an interval. In 4, I say, solve the compound inequality and write your solution as an interval. So in that case, I am looking for that kind of solution. Now, there are other situations. The graphs don't always kind of fall where they just overlap in the middle. Like, what if my two graphs did this? What's the intersection of these two graphs? Is there anything that's in both of them?
0.
Well, 0 is actually like not quite in that one. So it's not in both of them. Do you see, unlike the last one where there's a bunch of numbers that are in both of the sets? So those all go in the intersection. Here there's nothing. So this solution is called the empty set. It can be a 0 with a line through it, or it can be sometimes these open brackets, or you can just say empty set, which means there's no solutions. There's nothing that can do both of those things. If I were to look at this as intervals, this is really saying like x is less than 0, and this is saying x is bigger than 2. And if I put an and there, like there's no way you can be less than 0 and bigger than 2, right? I mean, you can't. You have to be one or the other, but you can't be both. So there's no intersection. So that's certainly possible with these. We also have a second one, which is called or. Mathematically, that's called the union. And it includes elements in either set. So they don't have to be in both to be in the union. They just have to be in one or the other, or they could be in both. Let's try x less than 1 or x less than -2. So x less than 1, x less than -2 looks like this. So the union of these two includes anything that's in one set, or so as well as anything that's in the other set. And what I can see here is that everything in this set, every number up to -2, is also in this other set, as well as all of these things, right? These are in one of the sets. So the union here in this case is actually just this whole set here. It includes everything less than 1, every number less than 1. So as an interval, that would be -infinity up to 1. So what I think about with the union is like taking the two sets and just smashing them together. And then that creates one set, and that's the union of the two. The intersection is only the parts that overlap, right? Those are the parts that I want to include in my intersection. So they're two different set operations, union and intersection. The intervals that I get are the same kind of intervals that we had before. And depending what they look like, the union and the intersection are going to create sort of different looking things. Sometimes they're overlap, sometimes they don't. Questions about either of those? And I cursed us, right, by saying so good with questions. No, it's fine. Maybe this makes sense. Let me show you one other example that comes up quite a bit with unions. Focus there. Sorry, that didn't work. Focus is not perfect here, but maybe it'll catch up. Try one more. There we go. That's better. Okay. So what about if I have these two sets? X less than -2. Here I have x bigger than or equal to 1. And what if I join those with an or? We saw when it was an and, it was an intersection, and there was nothing that overlapped. But an or is different. An or is going to include all of these things, and it's also going to include all of these things. So all of that stuff is in an or a union. The problem is it's not one interval. An interval is sort of like a continuous chunk, and there's one interval here, then there's a break, and then this other interval over here. So this is a fine graph of the solution because actually the solution includes all of those things. But if I were to write this as an interval, I'd have to write it as two separate pieces. So this piece is one interval. And then I would have to just use this U symbol. So this is union. And stick it together with this other interval. There's no way to combine those into a single interval because they're separate. They're two separate things. So this would be the interval notation. Questions about that?
Can you show us one more and example, please?
Yeah, definitely. Let's try. Let's try this. Let's do -2 times x plus 3 is bigger than or equal to 10, and minus 3x is less than 9. I made it up. We'll see. It'll work out. So what we have here is a compound inequality because of the and each of these are little inequality problems in their own right. So it doesn't actually, I mean, it adds a little extra work to the problem, but you just want to solve each of these on their own. And then once you have them solved, you can put it together with and. So I'm going to start by distributing that. And then I'm going to add the 6 over. Then I'm going to divide by minus 2. And I'm going to remember, because I divided by a negative, this switches. X is less than or equal to minus 8. Okay. And I do the same thing over here. This one's a little easier. I divide both sides by minus 3. I switch the sign again, and I get x is bigger than minus 3. So no matter what the compound inequality is, it doesn't change what I do there so far. X is less than or equal to minus 8. So that's a solid circle there. Less than or equal to looks like that. X is bigger than minus 3. So that looks like that. So let's see there. What is the solution? Remember, this is an and inequality. So what numbers do both of these things? This is one like we saw one before like this, right? There's nothing there. It's the empty set. No solutions. Notice very different from the one up above, right? The one up above, like visually, is kind of the same. The two individual sets are separate from one another. But this one is an or inequality, so I include anything that's in both the sets, so they both get included. But with an and inequality, I'm excluding some things. Exactly right, empty set. And I'm fine. I'm not too picky how you write that answer. So any of those would be fine for me. Was that helpful? I guess it kind of ended up being the same in the end as one of our other examples, but
Yeah.
okay. Great. So, I would say these compound inequalities and inequalities in general, they do not have to be, well, I don't know, like they're not inherently difficult, but there is a lot of like new little vocabulary and small choices that you're having to make, right? Like open and closed and left and right and how all these things go together. So in that respect, they can be difficult. But if you can focus on just figuring out kind of what each little piece does, when I choose a solid circle, when I choose an open circle, you'll find it'll start to fit together for you. And I mean, the reality is, I don't know if we talked about it or not, but with math, anything you don't understand is really hard, right? So it's not really about whether it's easy or hard. It's just a question of whether you understand it or not, right? So there may be very sort of difficult things, but if you understand them, they're not, right? They don't feel difficult. So I think that's something to focus on as you move through the course, right? Things that seem difficult are just things that you don't fully understand yet, right? But you will, right? With work and patience, right? Trying to get there. Okay. Any other questions about inequalities? I mean, it's a quick overview. There are more examples within those little D2L lectures. I would encourage you to look through those as well if you're stuck on any of these problems. Excuse me. Okay, so our last topic here for today, the last homework that you have, are absolute value equations. Either absolute value equations. Right? And an absolute value equation, remember, an absolute value of x equals the distance from 0. A lot of people just think of it as something that makes their numbers positive, which is like the effect of it, but that's not actually what it is. I mean, that's sort of a useless, I mean, not useless, but I can make numbers positive in other ways, right? But the absolute value is actually measuring the distance I am from 0. So it has the effect of taking a thing like 2 and not changing it, because 2 is 2 units from 0. But it has the effect of making a -3, right, +3, because that's 3 units from 0, right? It doesn't care which direction you are for distance. It's just how far. And so sort of not that much to it when you have numbers, but if you add in an equation here where you have an x involved, then things start to get a little bit more interesting. The absolute value of x equals 7. Well, I think you can see just from our example above that there's 2 numbers that are going to make this equation true, right? One option is that x just equals 7, right? Because absolute value of 7 is 7. But also x could equal -7, right? If the distance from 0 has to be 7 on the number line, right, there's 2 numbers that are 7. So we end up with 2 solutions when we are working with absolute value equations. Okay? And that's different than our other linear equations where we just had one solution, or there are some other options, right? No solutions and things like that. But we want to look for 2 solutions when we're dealing with absolute value equations. Okay, here's another one. 2x plus 3 equals 5. Well, it's actually the same kind of problem, right? Instead of just an x here, I have a 2x plus 3, but whatever it is inside the absolute value, if it equals 5, this thing inside the absolute value could just be 5, right? Because then the absolute value of 5 is 5, and I can figure out what that is. Or this thing inside the absolute value could be -5. So this is what we do with absolute value equations, is we convert them to these 2 possibilities. And then that gives us 2 equations, but they're both equations that we can solve, right? These are just linear equations. So I subtract the 3, divide by 2, and I get x equals 1. Over here, when I subtract 3, I get -8. When I divide by 2, I get x equals -4. So I get 1 and -4 are my solutions. And you can check it, right? When you put in -4, I get -8 plus 3, which is -5, and absolute value of -5 is 5. 1 is, of course, going to give me 5 directly, right? And that's what these two equations were designed to do, right? One was going to give me the -5, and one was going to give me the 5. A little note here. You must isolate the absolute value. And what I mean by that is if your example is this, x plus 1 minus 3 equals 7. Right now, the absolute value is on the same side as this number, -3. And if I try and write this as this equal to 7 and this equal to -7, it turns out it's not going to work. It's not exactly right. What I need to do is add the 3 to both sides. Now the absolute value is isolated. It's alone on one side. So now I can do that translation. Right, one side equals 10, one side equals -10. And x equals 9 or -11. I'm always looking for two solutions there. But I have to be a little careful about how I translate it into those two. I never want to do anything inside the absolute values. Turns out it's really hard to do. It's like I can't subtract the 3 here because that 3 is inside the absolute value. It's stuck in there. I can't take it out. The only thing I can do is try and translate this into two different options. Okay, questions about that? Again, it's a fairly short overview of absolute values, but it's certainly enough to get you through, I think, hopefully the rest of the homework. But again, there's other resources as well as the My Math Lab to ask questions through, so I can help you understand and figure out what you need to be successful with the homework. So keep working. You know, sometimes these sections don't go quite as planned. So, you know, if you're behind, you got to do your best to get caught up. You know, if you do late work, it's only worth 50%. And so that's, as long as you have most of it done, that won't hurt your grade very much. But if you're missing a couple assignments, that 50% is going to hurt a little bit, right, for this homework assignment. And that's, you know, it's for your own good, really, because it's forcing you to get it done. It's giving you a little motivation to get it done so that we don't get behind. Right? But if this, you know, if you kind of didn't maybe manage your time as well as you would have liked this first kind of 2-week section, you've got another 2-week section starting. So it's a chance to get into some good habits and get a good routine going that hopefully you can carry through the rest of the semester. That'll make your life a lot less stressful, and you'll do a much better job of learning it if you can come up with a consistent plan for getting through your homework. It'll give you more time to get help if you need help, and it'll provide a little flexibility in case the week doesn't go quite right, you get a little sick sometime or some, you know, stuff happens. So if you get started early, the stuff that happens, you know, typically doesn't throw you off too much. Okay, So again, there is that section 2 schedule posted. I'll probably send out an email with that once I post the key to the take-home work. Again, I'll start grading things probably on Friday for all of that. So please keep me posted with questions, stay in touch. It's great to see so many of you here, almost everybody, I think, from the class is here, so that's great. I will be recording that on D2L here as well, probably starting the end of this week. So you're welcome to stick around if you have some other questions. Otherwise, good luck getting everything finished, and I will see you in a week.